All right, so here we go. We're continuing on with the examples of definite integrals. And again, we will call this one basically example 1, part C, let's call it, all right? The third one on the slide. A definite integral from 0 to 1. You know, I had the steps for doing this up on the screen already. Now, here's one thing that's a little bit different about this, though. That integrand is a product. And you might say, where's the product rule for integrals? There isn't one, all right? So, for our purposes in Calculus 1, what we'll have to be able to do is perform algebra on that integrand. And fortunately, in this case, that's not a big deal. So I would just suggest we bring over that integrand and we do algebra to it, all right? Now, thank heavens that that is only second power. We're going to talk about what if that was the 38th power, and then we're going to have to do something else. But here for a while, we should be able to do some easy algebra to simplify these integrands. And so if you FOIL that out, distribute it, and then distribute the x cubed, so that's just algebra, all right? And so in some cases, we will need to do some algebra to the integrand in order to set it up for us to be able to integrate it. Because all we know how to do so far is integrate terms and powers. If that was a higher power, 38th power, this isn't going to work very well. And then we're going to talk about how to do a thing called substitution in a case like that. But for the time being, these will be ones where you'll be able to simplify them pretty easily. So sometimes a prelude to integrate is to, I need to make it rhyme, simplificate, all right? So you simplificate the integrand. That's not really a word, but anyway, just do algebra to this. I want to make sure that's right. So x cubed plus 2x to the 4th plus x to the 5th. Well, yep, it's good. Algebra, all right? Algebracate. Now we can do the calculus, which would be to integrate this thing. So we find the antiderivative of each term. And so that would be x to the 4th over 4. N plus 1, n plus 1, all that. This will be plus 2x to the 5th over 5 plus x to the 6th over 6. Now, I always want to remind people, if we did not have limits of integration, we would put that constant on there, and we're done, all right? And that would be that earlier assignment that we did, assignment 24, where all we did was find the antiderivative. But if it's got limits of integration like this, and don't have the constant anymore, we're not done. There's the issue of evaluating. So now it becomes arithmetic, basically. You know, what's this look like to you? This says put b into that antiderivative, capital F of b. All right, so capital F of b in this case would be to go through and put a 1 everywhere there's an x. 1 to the 4th over 4 plus 2 times 1 to the 5th over 5 plus 1 to the 6th over 6. That would be that one minus, and then we put the lower limit of integration in there. Now in this example, I think that's going to be pretty easy arithmetic, isn't it? Because that's going to be 0. And I'm going to write it out anyway. You can't always depend on that lower one being easy. So that'd be 0 to the 4th over 4 plus 2 times 0 to the 5th over 5 plus 0 to the 6th over 6. Stick that one in there. All right, that's all going to be 0 in this particular example, although it will not always be. Right? If that was a number other than 0, there'd be more work to be done. And then you crunch the numbers, and you know how I am on this. So it turns out that in fraction form, this comes out to be 49 over 60, which in turn is approximately 0.816. All right, I hope I did my arithmetic correctly on that. I believe I did. If not, it's on the internet forever, and everybody will think I'm terrible. Oh well. I don't think you're terrible when you mess up, okay? We all mess up, it's just the way it is. Okay, so there's that one, and let's pause and we'll enjoy a few more.